In this lesson, I'll show you two examples on how to find the inverse transforms of a function. Question number 1 reads, if f at s is equal to 4 over s squared plus 16, find f at t. Now before we start answering this, to go from f at s to f at t, you're technically taking the inverse of f at s. So the Laplace transform, which I'll denote as Laplace inverse of f at s, is equal to f at t. And you're going to find out that the inverse is often harder to find than transforming the function f of t. So starting with our function f at s is equal to 4 over s squared plus 16, what we have to do is match this with the table that we have underneath. Let's see if we can match that. Look at this column and see if it looks like this equation. 4 over s squared plus s. Now if you look at number 17, you'll see that you have a over s squared plus a squared. Maybe that works. A over s squared plus a squared. If this works, a has to be 4, because 4 to the power of 2 is 16, that matches, and placing 4 into here gives us this 4. Also, s squared hasn't changed, therefore f of t for this function, the inverse, has to be sine at. Sine for t is equal to f at t. Let's move on to question 2. This time they want us to find y if the Laplace transform of y is equal to 5 over s minus 7 to the power 4. Remember, this is just another way of writing f at s. So let's try to match this with something that's found in this table. Remember, it was 5 over s minus 7 to the power of 4. If you look at number 13, we have n factorial over s minus a to the power of n plus 1. Maybe we can use this to model our function. Let's write it down. We have n factorial over s minus a raised to the power of n plus 1. If we're matching this equation to the following, then a has to be 7. And n, given that this is 4, has to be 3, because 3 plus 1 is 4. So let's see if that works. N factorial over s minus 7 over 4. N factorial is actually equal to 6, so there's a problem here. What we have to do is look back at what this represents. It represents t to the power of n e to the power of at. Now we said n was equal to 3, so we have t to the power of 3 e to the power of a, which we found to be 7 times t. Now to compensate for the fact that this is 6, where we have a 5, we can use a little bit of algebra. If I multiply this by 5 over 6, this 6 and this 6 will go away. Therefore, our equation we can multiply by 5 over 6. And this doesn't change how we integrate the function, because if we were to take the integral of this function, you would be pulling out this 5 over 6 anyway. Therefore, you're allowed to do this for questions like these. And so there you have it. Two examples on how to find the inverse transforms of a function.